We're going to look at another applied problem of using the sum and difference identities. So I'm told that the sine of an angle alpha, that's just what that letter is negative 3 over 5 for pi less than alpha less than 3 pi over 2. And cosine of beta is 5 over 13 for 3 pi over 2 is less than beta. It's less than or equal to 2 pi. So, first of all, sine of alpha is equal to negative 3 over 5. So let's remember where we are. When we talk about when we're talking about sine and cosine of angles now, remember we're in angles in standard position, meaning we're going to draw our coordinate axes, and that is a negative ratio, right? So we have to consider where sine is negative. Well, sine is negative in this quadrant and this quadrant. This here tells us the exact quadrant we're in, because it says that the angle that we rotated is between pi radians. Well, pi radians would bring me here, and 3 pi over 2 radians brings me here. So if my angle's in between those, that means, I'll write this as my alpha picture, that means that my angle must have landed me in this quadrant. Okay, so like we rotated that's alpha. And the sine of alpha is negative 3 over 5, so we use our reference angle as usual, negative 3 over 5. And we can use the Pythagorean theorem to find this, which we would find is a negative 4. Okay, great. So that's important to get down. You'll see why in a second when we use this table. Let's do the beta one. So we're told that the cosine of this angle beta is 5 over 13. That's a positive ratio, and cosine is positive in these two quadrants. But then this tells us the exact quadrant we're in. 3 pi over 2 brings us here, and 2 pi brings us all the way around. So if the angle's in between there, it means that we landed here. So beta was that angle. Now cosine is 5 over 13, adjacent over hypotenuse. And by using the Pythagorean theorem, we could determine that this is a 12. So I'm going to leave that detail out, just in the interest of time. Okay, so now these diagrams are key. So you want to be able to do those correctly, because now, right, ultimately I want to be able to answer these questions down here. So let's go down and answer, or let's at least take a look at the first one. I'll leave the second one just because I don't want this video to go too long. I'll leave the second one for you to try after we do the first one. But cosine of alpha minus beta, well, it's a difference of two angles. We don't know those angles, and we don't care. Right? We don't care about recovering these angles. What we want to know is the cosine of their difference. And so, since it's the cosine of a difference, I can use my cosine of a difference formula, which is cos op sine. See if you've picked up on that phrase, why it works or why it's helpful. And then I would just alternate alpha, beta, alpha, and beta. Great. So now what I need to know is I need to know the cosine of alpha, the cosine of beta, the sine of alpha, and the sine of beta. So this chart really is just to help me organize that information. So I have my angle alpha. It's supposed to be alpha. It doesn't look quite like an alpha, but it's supposed to be alpha. And so what is the sine of alpha? Well, that's what we were given, so we can just put negative 3/5 here. Cosine of alpha, well, I'm just going to go to my picture here. Cosine is negative 4 over 5. And it doesn't look like tangents at all needed in this problem, so we can put it if we want, but it's not really needed, so I'll leave it out. And then beta, the cosine of beta we were given, so cosine of beta we'll just put here. And then the sine of beta, we'll look at the diagram, would be negative 12 over 13. Great. And again, this isn't needed yet, or may not ever be needed, but so we can just ignore these two. And now we substitute. And let me give you a heads up of what the biggest mistake is, as I've been teaching this for a few years. This is the biggest mistake, so don't do this. Ready? Do not do this. People love to do this. They say, oh, cosine, or students love to do this. Cosine alpha, cosine alpha negative 4/5. And then they proceed and they write cosine of, so again, I hope you're not copying this down. This is an example of what not to do. Cosine of beta is 5/13. If you, at this point, don't understand what's wrong, look carefully. This chart is supposed to tell me that the cosine of beta is 5/13, not beta. Beta is an angle, we don't know what it is. So we're not substituting the 5/13 in for the beta. So let's get that off the page immediately. We are substituting the entire trig expression. Cosine of alpha is negative 4/5. So that's negative 4/5 times the cosine of beta would be 5/13. So the word cos is gone because it's the cosine of that angle that equals 5/13. And the sine of alpha is negative 3/5. And the sine of beta is negative 12/13. And so now we can reduce these fractions. Negative 4 times 5 is negative 20. 5 times 13 is 165. And then I'm adding that to negative 3 times negative 12 is 36 divided by 165, which equals 36 minus 20 is 16/165. So we don't know what alpha and beta is, but we know what the cosine of alpha minus beta is exactly. It's 16/165. All right, so this would be an excellent problem to try now to sort of test your chops. Because it's a tangent one. Now we've done one, so take a look at a prior example if you want help on how to do a tangent one. But I think this is a good place to end the video. Just keep in mind that you want to know what that means, what those mean, and you want to make the appropriate substitutions once you finally get your sine or cosine identities down.